Mythical Man-Month. Fred Brooks, as I mentioned, was project leader for the operating system for the IBM 360, which is a brand new line of mainframes that IBM was coming out with in the 60s. The project was about a year late. I talked in the book about mistakes he made that caused it to be late. And this book is important because it was written 40 years ago and it still touches on what are pretty much the root issues in most large software projects, and frankly a lot of small software projects as well. Yes?
Are these on the website?
The slides will be on the website, yes. Once again, all my lectures, I record them, I will post the videos and the slides on the website because this will be useful. This is why, you know, take notes for whatever is meaningful, but you can actually go back and rewatch the lecture. These lecture slides will all be there when you take your midterm. So you can go look them up on the website. My goal here is not to test your memory. My goal here is to test your comprehension of material, your ability to get to the references that are relevant. Software failures, it's hard to quantify the actual cost annually in software failures, but 100 billion is probably as good as anything. Lots and lots of projects that fail outright or are significantly late and over budget and or fail to deliver the benefits that were promised for the money. Yes?
Is failure defined as I paid for it and I didn't get anything, or I way overpaid?
Well, actually, it's what I just said. Either the project ends up just being canceled altogether, or it is way late and over budget, so it costs far more, which affects your return on investment for the project, or in some of those cases, the benefits weren't what you expected. You know, I just spent $100 million on this new system, and frankly, I'm not saving any money on it. So, you know, what was the benefit of $100 million? As I mentioned, I've actually testified before Congress before, which, as I also would think I mentioned, just shows any damn fool can testify before Congress, and many of us have. I've actually done it 3 times. But I was talking specifically about the need, these were hearings back in around 98 to get the government moving on the Y2K problem. And the big concern is that, you know, we have such a bad track record within the software industry that government needed to pay attention to it. This is a comment I made as part of my testimony. By the way, what happens when you have testimony is you prepare this, it has to be able to be read in 5 minutes, and usually you don't actually get to say it. It just goes printed into the record, and then if anyone wants to ask you questions, they ask you questions. Having been there. But this comment that the Mythical Man-Month is a classic book that could be regarded as a Bible of information technology because it is universally known. I promise you go out in the industry and say, hey, have you ever heard of the Mythical Man-Month by Fred Brooks? A lot of people will not. Often quoted, usually 2 things, you know. Adding people to a late project makes it later, Brooks' Law, and or you know, you can't produce, doesn't matter how many women you have, it still takes 9 months to produce a baby. Occasionally read. So here's the tricky part. Have you ever heard of Mythical Man? Oh yeah. Have you ever read it? Oh, well, no. Do you own a copy? Oh, well, no. One consulting project I had, which was a project that was seriously late and had problems, I got permission from the vice president of the division where I was consulting and bought 30 copies of Mythical Man-Month and handed them out to everyone from him through all the layers of management, staff, and developers. And said, you know, you need to read this. 6 to 8 weeks later, I went through and started surveying people, and literally no one had read it. And then, you know, I'm just sitting here thinking, these are the problems they're having. No one wants to read the book. Occasionally read and rarely heeded. You will find that managers, whatever lip service they may give to the Mythical Man-Month, it's like, well, it's going to be different here. Yes, we really do need to double the programming staff and get this done sooner. It's like, no, it doesn't work that way. Chapter 1, the tar pit. Brooks has a 4x4 diagram, which is still relevant, though for most of you, it's not going to be, all 4 quadrants aren't going to be relevant. First he has is a program. Something that you're writing for yourself. How many of you have written a program for yourselves? Okay. Down here, you have a program that's a product. In other words, this is something that you're going to deliver to other people, they may pay you for, so on and so forth. How many of you have done programs that are actually products people have bought for? Right? Very good. What's the difference between this and this?
One's fun, the other's not.
One's fun and one's not? Yeah. Pretty much. But what are some, I mean, why is this? He says this is 3 times the work of this. Why is that? Why is it harder?
You have to test it to make sure it's actually doing things you want it to do.
Okay.
It's hard to get something to run on my computer and yours.
Oh yeah, yeah.
You need to make it actually maintainable long term.
In theory. Yeah, you have to. Okay.
You can't trust your users to do sensible things.
Boy, ain't that the truth.
Sometimes, like, the people buying your product make requests.
Yeah, oh yes.
You have to work with 10-year-old crappy code.
Boy, that's true.
You have to make it generalized to everyone and make sure that they know how to, like, it's understandable how to use it for everyone, not just for you.
Yep,
It's a representation of you or your company, so you want to make sure it's polished and presents you well.
yep,
On top of that, you have to have documentation so they know how to use what you've made.
yep,
You're setting your own requirements for a program, it's often not the case for a product.
yep. This is, I mean, this is much harder than this. Over here, he has what he calls a system, and he's referring to system-type software, operating system. But I think the way he uses it, it can be expanded into, I mean, not many of us, how many of you have written utilities for yourself? You know, you've done something that's okay, this is something that I'm writing, that I'm going to run, and it's going to work on my computer. And then you have a system-type program, operating system, IDE, library, development tools, things that people use to create programs themselves. You have a system product. And he says, this is 3 times harder, this is 3 times harder, this is 9 times harder. I did a lot of work back 30 years ago for what was then known as Borland, which was a company that made PC development tools, Borland Pascal, Borland C. And I did a lot because I could write, and I was an actual developer who understood these languages and operated, tools and so on. I did a lot of their manuals, their user and reference manuals. And Philippe Kahn, who was the founder of Borland, who was a good friend, said, never do commercial development tools. He said, your customers are angry with you all the time. He said, if you think there's a problem with a bug in a regular application, try having a bug in a development system. And particularly a bug in your compiler. He said that the sense of anger and betrayal, he says, it's incandescent. Why? It's pretty obvious, I think, to most of us. Why does software get so hard and so complex? What are some of the other reasons?
It's very fragile.
It can be
Doesn't take much to break it down.
It can be very fragile, yes.
Time passes, people forget.
Yep,
It expects you to be perfect.
yep. What's your sense when you run across a bug in software? Huh?
I usually think I messed up somewhere.
Okay, yeah, sometimes we think, or you just swear it. There are bugs in Microsoft Word that I've been struggling with for over 20 years. It's like, why can't they fix this? You know, why do they do this funky thing with paragraph formatting when you have a page break in there? And you go to the next page after the page break and you do something that changes the formatting in the paragraph just before the page break. That's been there for 20 years. I kid you not. I do a lot of writing. I run into that all the time. What are the, yes?
I love the idea of how software is like one step removed from like thought, so it's like very tractable, and because of that, you can basically do anything you want to. It also means that it's very kind of sleuthy, and so like things can change really fast, and you don't know if you change. It's so easy to change it.
Yep.
And it makes it fun. Right?
Yeah.
It seems like every new thing you add just compounds all of the previous bugs that may be lurking there.
Which is an important issue. Okay. Yes.
When you're wrong, no one stops you from keep going. Yeah.
Yeah.
Another thing that I run into a lot is time passes, your dependencies need to get updated from other packages that you're depending on, and you need to spend a ton of time refactoring that, as well as keeping your own code up to date. And by the time you finish your project, oftentimes there's some new shiny thing that's out, and everyone wants to switch over to that now.
And we'll talk about that a lot. Yeah.
All of these problems just easily multiply for every person you add to a project, right?
Yep.
Well, I think also sometimes you end up with people that try and fit a square peg into a round hole because they haven't learned specs.
Yep. Well, and this is all stuff we're going to talk about. Here is an important realization. I can't recall how long ago this hit me. I can go back, you know, to my early days of programming, where pretty much you had the whole system and you knew everything. Like when Wayne Holder and I did Sundog for the Apple II, we used Apple Pascal. I wrote a 6502 and P-code decompiler to decompile the whole kernel, so we could do some stuff in there. And we literally, I knew the entire memory map down to the byte. I mean, memory map was 64K, so it wasn't like there was a lot there. But I wrote the whole graphics library from scratch. You know, I knew exactly what was living in each component. Stop and think now. If you're writing, let's just say an app for, you know, an app for iOS or an app for Windows, how much other software do you depend upon? What do you draw upon? It's stuff that's constantly changing, as people notice. And here's the problem. When you have so many interconnections, the upper bound of your quality is determined by the lowest quality component of all those systems you rely upon. You don't have control over your overall quality. It does you no good if you have just a perfect, flawless program and it's calling a library that's got bugs in it. That gets you nowhere. Okay, now, Brooks also talked about the joy of programming. What do you like? Why? I mean, look at you. You're all seniors in computer science. You obviously stuck it out this far. Why do you like programming? Thoughts? Yes.
Creating something that wasn't there before.
Yeah.
You make things that do things, like it's not just theory, it actually does something.
Yeah. You know, books people read. You do things that put stuff on the screen that do actual work. Other thoughts? Why do you like programming? Of course, being seniors at this point, you may decide you don't like programming. I've got these classes to get through, and then I earn some money. Yes.
Creating stuff that other people can use.
Yeah.
It takes a lot of money.
It can. When I went into computer science, I didn't think about the money, but frankly, it's been very good to me over 40 years. And I've got several kids who all work in information technology, and I can't remember. By the way, please forgive me in advance if I repeat things that I've said in earlier lectures. I have a lot of things, little things I bring out, and I don't always remember what I've said or not. But what I've told my kids is, the challenge in information technology is you're going to be learning new stuff the rest of your lives. Said the advantage is that people will pay you to do it. And they will. And It's like, oh, we need you to learn this library, you know. Go work on this. Oh, hey, cool. Something new. Other thoughts?
Yeah, I actually really like that aspect because a lot of the mundane stuff, the stuff that you already know, you can just automate a lot of it. And so you're constantly learning new things, and for people who enjoy learning, that's really exciting. Like, it's not the same thing over and over. It's exciting and new.
Yep. Other thoughts? Why do you like programming? Why are you considering it for a living? Yes?
Going along with the always learning, you're always solving a new problem. And oftentimes those are like real problems that impact actual people. So you're kind of on like the forefront of human endeavor in that respect,
Yeah.
as opposed to doing something that's just repetitive and not necessarily solving a problem.
Yep.
In that early essay that we read, they talked about that as if you're doing something that somebody else has already solved, what are you doing it for? And that's a problem that doesn't exist in other fields.
Yeah, actually, that's very true. By the way, how many of you have either had qualms or have had people come up to you saying, I don't know why you're going into software engineering, AI is going to be doing all of this, and... How many of you have heard that? Okay. You know how long I've been hearing that? 40 years.
Still hasn't happened.
It still hasn't happened. And it won't happen. And you guys have touched on something. What you have happen is the stuff that the problems that are solved get automated. I wrote my own graphics library for Sundown from scratch. If I were doing a game now, obviously I wouldn't do that. I don't have the years it would take and millions of dollars to do something, yeah, like one of your standard off-the-shelf game engines. But the problem is that problems that are solved like that are not the competitive edge. And you have the same thing I mentioned about upper bound of quality. There have been, repeatedly over the past 40 years, various program generations, program creation systems. You know what they produce? They produce crap. Mediocre crap. Because it's only as good as what the system can actually produce. You basically remove the creative problem solving and the inventiveness that's required. Yes?
Are applications like that considered a quadrant lower right type application? Is that kind of where that would fit?
In theory, it's like this, but it's this that's trying to spit out this. So it's now sort of even, it's why it's limited. It's something that's supposed to be a system tool, but it's trying to spit out a program, you know, either just for one-off or for this. And what you get is really mediocre software. And if you go back, and you're all probably far too young for this, but back in the 90s, the big buzz was fourth generation languages. You know, we've got fourth generation languages like Power Builder. Executives can program. They can lay out their screens and put up the data. You know what? How many of you have ever used or even heard of Power Builder as an application builder? Okay, I rest my case. That was a big thing in the 90s.
Well, like WordPress, you know, right? So like WordPress allows people now to build websites that are pretty good, but
Well, WordPress, yeah, but WordPress doesn't build the website for you, and you know, you buy someone's theme and you start adding stuff. I use WordPress, but it's not a program generator, and it's more a set of frameworks. And if you want to try and customize stuff, you know, you start dabbling in PHP, or you know, you buy themes and you buy themes. You look at them and say, I don't know how to make this work because this is a badly written theme. I've had that experience too. Problems with programming. You must perform perfectly. Computers are unforgiving. They're not only unforgiving, they can multiply your mistakes very quickly.
But they do exactly what you told them.
But they do exactly what you told them. Someone in the class has already mentioned this. Other people set your objectives, provide your resources, and furnish your information. In other words, you're expected to create this useful, if not best-selling program, But you've got people saying, well, it has to do this, and it's got to do that, and this is what we want. And it's like, well, it doesn't work that way. Here is, and we'll come back to this a couple times in the class, but I'll tell you right now, here's one of the big pitfalls you have. How many of you have had the experience of getting, either at work or even just on your own, getting some code working, and someone, your boss or a friend, says, boy, could you make it do X? You smile and say, yeah. Bam! And it doesn't. And they're like, whoa! You know? And they say, can you make it do Y? And you say, well, no, I'd have to rewrite the whole program. I say, but why? I mean, you know, you did X, it took you like 30 seconds. You changed a few lines and everything works. Well, it's different. I had this, and I'll come back to this, I'll tell you in advance, I'll come back to the example. Did a software startup, I was chief architect for a software startup doing a design-oriented desktop publishing system. And because of how the whole program was designed by the founders, their intent, it was a typographer and graphic designer, they had very rigid constraints on the design, okay? And we closed venture funding, we hire a permanent CEO, and we're developing, and we're probably just months away from shipping, and the CEO, Larry, comes to me and says, you know, I'd like to be able to rotate headlines. I said, oh, Larry, you can't. He says, why not? He says, you know, Xerox Ventura does it. He'd come from Xerox Ventura. I said, it's because, Larry, the architecture literally will not support that. We would have to do significant rewriting of the entire underlying framework to allow you to arbitrarily rotate a headline. And he bugged me about that for months. Like, why can't you guys rotate headlines, Larry? He said, you know, do you really want to add like 6 months onto this project? We would have to break so much stuff and rewrite so much stuff to get that working. This is experiential.
That was my question, is what do you mean by that? But anyways, I couldn't think of a use case for rotating headlines.
Well, you have a column of text, and you've got an embedded headline. And he wanted to do an arbitrary rotation so I could grab one corner of it and make the headline go like this. I can tell you that Mike Parker, the co-founder of the company, and Vic Spindler, who's the other co-founder, Mike's an internationally, late Mike, internationally known typographer. Vic was a nationally known typographer. They look at this and say, no, we're not going to do that at all. That violates everything we're trying to do. This issue, your authority is often not sufficient for your responsibility. How many of you had that experience? They're saying, well, you got to make this work. And you say, well, I have to do X, Y, and Z, and I've got to get this. Oh, no, you can't do that. Experiences. Anyone want to share experiences? Have been through that? Yes?
We're starting to go to a microservice architecture at the company I work for, and they want us to have easily extend where you can grow it, right? So theoretically, we want to Dockerize, but we've been told we are absolutely not allowed to use Docker because a different division in the company had a bad experience with Docker, so we're not allowed to use it.
That is so classic. That is so classic. Okay, we've already talked about this. You are often dependent upon other people's programs, which often means other companies' programs, which are less than perfect, so you have that upper bound issue. Brooks points out, designing grand concepts is fun, finding nitty little bugs is just work. Oh man. You know, and Brooks, this is an important point. One of the most important things that Brooks says is that you will spend 50% of your project time in test and debug. He says no one schedules that much time, but if you actually track the project, you will find you spend 50% of your time in test and debug. That's because all these little problems all sort of collect to the end. Remember I said deferring the hard stuff? You know, how quickly can you prototype a user interface and get some flashy stuff and have menus and so on? You can do that very quickly. Here's the problem. You do that. You get the user interface running and your management looks at you and says, well, you're almost done. Oh, no. This is a facade. There's nothing behind this. It's like, but I can pull down all the menus. Why isn't this done? For years I argued that what you should have is a quarter scale PC. And you should do all your prototype demos on this quarter scale PC. And then say it's going to take us 6 months to make it work on a big one. Because, you know, in construction and architecture, if someone comes to you with a physical model of a building, no one says, hey, I can see the whole building, let's move in. But with software, that's exactly what they do. They see your prototype, it's like, hey, it's done. You know, don't you have to just add some things back here? Debugging is slow, and someone already mentioned this. The product is often obsolete before it's complete. You work and you work, particularly if you're late getting to market. You work and work, and you get there, it's like, oh, someone's already got something better. What are some other painful things you've discovered about software engineering? Thoughts? Yes?
I was just going to say about the bugs, I feel like the longer you search for bugs, the less productive you get. As you get worn down by the, I can't figure it out. Like when you're designing cool stuff, you can move quickly because you're at your most productive time. But when you drag out searching for a bug, you get less and less productive as you go on.
You feel less productive. It's actually important, but yes, you feel very less productive. If you're not doing anything new, you're just trying to make what you wrote work. Yes?
Sort of on the flip side of, you know, being able to learn lots of new things, I find that there's been some occasions when I've accidentally become the expert. And people start like, okay, well, you learned this, and can you please just do that? And like, no, I've only learned 2 or 3 things to get the bare minimum going, but it's too late, and it's suddenly you are the subject matter expert for whatever you were researching.
There's a comic strip that I ran across just a few months ago that does that, with someone saying, someone being asked to help out. I'm trying to think of what language. It may have been Python. It's like, can you help us with this? Oh yeah, I'll learn this. And it goes through the sequence of, you know, people saying, oh, so-and-so knows Python, let's make him the project lead, and then he gets involved, oh, he's speaking at this conference, come speak at this conference. And finally someone asks, how did you become an expert on Python? He says, funny you should ask that. Yes?
Some experience I had was just like getting too much, like trying to focus on a perfect product before you're releasing it, where you're just adding more and more features, and then you kind of lose track of your hypothesis, and you release, it's just been years at that point.
Yep.
Thinking that people with PhDs in mathematics can write a program and deploy it at scale.
Yeah.
That happens when I work, like, oh, they wrote this cool machine learning algorithm. We can just plug it in and let it go, right?
No, yeah, thanks.
Not when it runs in queue.
And boy, that's an important point, because there's a lot of stuff that you can do. Again, proof of concept, and this works on the small, but trying to scale it to production environments can be a disaster. Root causes of software project delays and failures. We have poor estimation. I actually just answered a question on Quora, where someone said, why are so many projects so late? I said, let me tell you all the ways. All the ways, and we are very bad at estimating software, because we get back to Philip Armour. We often don't know what we don't know. And the more inventive and more novel what we're doing is, the more likely that we're going to run into some long dead ends. But beyond that, we tend to be optimists. Mark talks about that. It's kind of like, oh yeah, simple matter programming. I know how to do this, this, and this. And we can get to 60 or 70 or 80% of the solution, sometimes even 90% of the solution. And it's like, yeah, we're in the home stretch now. And then you run into all the hard problems and things that don't scale or don't work, and it's kind of like, oh, this isn't working. We have to punt, we have to rethink, we have to refactor, we have to re-architect. Our estimation progress, lots of people are working on this. We've put in, we've had 10 people working per year on this. Surely we must be close to being done. Okay. Some of the biggest project failures have some of the biggest staff of people working on it. We often lack the courage to say we don't know when we'll be done. If I can teach you nothing else in this class, it's to be very conservative when your manager asks you for an estimate. And don't be afraid to say, I don't know, because I don't know everything I need to know yet. They may not like that. It may even be a career-limiting move. But having projects that go away late are career-limiting moves too. It's very hard to measure progress on a project. This is a visibility problem I think I talked about last week. You know, you watch a building under construction here on campus, you can pretty much tell, hey, you know, it's a hole, or there's a framework, or walls are up there, or, you know, all the walls are sealed like they're just doing finishing stuff inside. It is so hard to do that with software. It's so hard, even when you're working with the software, to figure out what the problem is. What are some of the, for those of you who have experienced software delays or even outright failures, what have been some of the other factors that you've seen that cause this? Any thoughts or observations? Yeah.
At our company, we underestimated the complexity of the API for software that we depend on.
Ah, there you go. That is so classic. And often the problem is the deep API. In other words, it's like, oh, we have all the call, here's all the function calls that we're going to call on the API. But it's like, well, actually, you have to call it in this order, and you have to know what your results are to know whether to call this follow-up or this follow-up. And by the way, there's bugs the software depending on. So, you know, we're working perfectly. Why are the results wrong? Yes?
One reason is wasted time and effort. Like, for example, someone will request a certain feature and then forget to request it. It's not even essential. So, like, you spend X amount of time trying to work on this and figure out bugs, and then they say, "Why are you even working on this?"
Yep.
Well, because you requested it, and they don't remember that. It's not just waste.
Yep.
A lot of times, requirements for a product will change.
Oh yeah, we'll talk a lot about that. That's a major factor, is changing and exploding requirements.
Sometimes you get interrupted a lot while you're at work to either help out with other programmers' problems, or someone just wants to talk to you about something at work while you're trying to work.
I have a cartoon. Rich Tennant used to do a comic panel in the San Jose Mercury News 20, 30 years ago called Fifth Wave. And he had a series of real programmer panels, and one of them was real programmers get most of their work done between 10 p.m. and 3 a.m. And having spent many midnight hours programming, it's for exactly this reason. People stop bothering you. Yes?
All right, estimates is, management refuses to believe estimate.
Oh, yeah.
You do it less times than what you say.
Yeah, management refuses to believe what you're saying. Oh my gosh. Yes, or they just don't want to accept it. Yes.
Just on that front, like, it's great for all of us to know the problem, but what do you do if the people above you don't?
We'll talk about that. Okay. And I faced that repeatedly. Here's the bad news. This was an inside, I was at a software development conference about 20 years ago and attended a session that was specifically on, you know, dealing with issues with management and so on within an organization. And the person talking, I should dig up my notes and see if I can figure out go back and remember his name. He said something that I found both immediately true and somewhat terrifying. He basically said the only way you can affect change in an organization is to walk in every day prepared to be fired. And I will tell you that's true. Now the advantage is being the consultant is like, yeah, they're going to fire me anyway. So trust me, as a consultant, I am brutally honest with my customers. And sometimes I don't like what I'm saying, and you know, we'll talk more about that. But I am brutally honest. It's harder if it's, you know, you've got a spouse and 2 kids, and this is your income, and you're trying to figure out what to do because you can't necessarily afford to hold on, you know, to lose that job or to start job hunting. There are ways around that. We will talk about that through the course of the semester. Ways to affect change in an organization or to try to without getting fired. Programmers are optimists. Yep. Sometimes it's our fault. And this is probably the most important. It's very easy to lose a day on a schedule. It is almost impossible to make it up. We tend to think, well, you know, I'll just work this weekend and I'll make it up. You know, it just doesn't happen. It's a ratchet, it's one way. And as Brooks says elsewhere in the book, I don't think we've gotten to that chapter yet, one of his later ones, how does a project get to be a year late? One day at a time. I have been there. I have been there. I know exactly, I know viscerally and from personal experience the truth of that, yeah.
I wanted to ask you about that specific topic because you mentioned it last time, but you said that you had to keep meeting with the stakeholders every month.
Yeah.
Were you giving a new deadline and failing it consistently, or did you push it out?
Well, we tended to push it out a couple months at a time. So it wasn't that it was a new deadline each time, but it was answering, do you think you're going to make your current deadline? And we always started off saying, yeah, and then a month later it's like, well, it's kind of iffy, but we think we might. And then it's like, okay, here's our new deadline. that was professionally agonizing for me because I had a great track record before that. And that's pretty much what set me on my whole professional focus on project management, why projects succeed and fail, because that was so professionally embarrassing and agonizing for me to have that happen. Product I thought was great. Unfortunately, we happened to pick, and we'll talk about this too, happened to pick a platform that wasn't successful. Anyway, what makes us optimistic in a program? Thoughts?
It makes it easier to start working on it. We don't think of the reality.
Oh, that's so true. That's so true. It's kind of like if we really knew ahead of time, we might not start it. That's how a lot of babies get started. Yeah?
I'm sure there's all kinds of reasons, but I find for a lot of personal stuff, it's like, think of all the work I'm not going to have to do if I put all this work in. You know, it's a very highly specialized form of laziness that feels really great.
Yeah. Why else do we tend to be optimistic?
I'm not trying to sound weird or anything,
no.
but I don't feel like in my mind I have failed at very many of the things I've set out to do. I have failed a lot, but it seems like I don't feel like I'm going to fail whenever I start anything.
Oh, no, that's actually an important thing. That was my problem at Pages. I've been out of college for my gosh, 15 years. And projects I didn't program for that whole time. Like I said, I burned out and spent 4 years not programming at all. But I had a great track record of many years of bringing my projects in on time. And I assumed this would come in on time too. I can go back and remember how optimistic I was in the early days of Pages and my schedules I put together, and we're going to do this, and we're going to get this done here, and this done here, and this done here, and boy, that experience just pretty much beat all that out of me. Yes.
And kind of going back, but it's the like not knowing the things you don't know. A lot of times you base your estimate on your previous projects, but they're not the same project. So you don't know what the bugs in the new project are going to be, or what the difficult new technologies are going to be. Like, how much time are you going to have to spend to learn one new thing that you didn't know from the last project?
Yep. Oh, yeah.
Based off what you're saying, like I find that usually when I'm coding a project that I've done something similar for, I feel like since I already have the knowledge of it, you know, time-wise I assume based on the knowledge of like how I already know how to do something, it's how long it's going to take me to code something I've never done before. Never works out that way, but
That's true. And by the way, I did go back to Adele Goldberg. She was one of the people who invented the small talk programming language, who said only optimists build complex systems. If we were not optimists, we would not be in this business. Okay? you have to be an optimist to be a software engineer. You just have to be an informed optimist. Yes.
Oh, well, that was my comment too. All the pessimists already quit, so.
Yeah. Man-Month. You know, I don't see much of this anymore. Well, I take that. There's still a lot of firms out there that think by doubling the staff you can half the programming done. And that if you have a late project, you just need more people working on it. My honest, after 40 years of this, you know what you want to do with the project? Want to take some people off. You want to take the right people off, but you want to find the least productive people and take them off, and what you'll find is that your best people will step up and the decision loop time be tightened tremendously. I would rather have a small team of really bright and talented software engineers than a large team of really bright and talented software engineers. Seriously, the same project. I'd rather have fewer people here in the middle.
Have you ever had someone who was like the weak link on a project, realize they were the weak link, and then like step up to the plate, or never?
I can't recall that. And in fact, the syndrome, and I'm trying to remember the name of the syndrome, it is often the weak links who are the least aware that they are in fact the weak links. And the bright ones, no, it's not the imposter syndrome, it's the bright ones who think they're not that good. There's another syndrome that basically describes...
Dunning-Kruger.
Huh?
Is that Dunning-Kruger?
Yes, Dunning-Kruger, thank you. Basically, the people who are least confident often think they are hot stuff.
The better you are, the better you are analyzing your own ability.
Yeah.
My question for you was, is there a balance between having your personnel staff be too small and too big, and how do you know?
You know, it's possible to have things be too small because there's simply too much work to be done, or you need some specialized skills. The problem, and we'll talk about this, is that there's a lot of software that doesn't, and this gets to the Mythical Man-Month thing, there's a lot in software development process that does not decompose. In other words, it's not like I've got this much work to do, but I can break it up into these chunks and do all of these in parallel. There is an inherent linearity to the software project on several levels. And as long as this is moving along the critical path, and we'll talk about critical paths in a few weeks, then you've got the right number of people. But like I said, all things considered, I would at the very least, I have a good friend, Bruce Henderson, worked for him for 20 plus years. He was the second programmer I hired at Pages. Has a saying, start out stupid and work up from there. And that works well, you know, with teams. I'd rather start with 2 or 3 really bright programmers and then add people as we know we need them. And possibly roll them off as we don't need them. Don't want to drag this on too long. This is probably one of my longest lectures. We're going to talk a lot about debugging and system testing. The main thing is that we always underestimate how much testing it's going to take. We always underestimate that, and because we have this tendency to defer the hardest parts of the code, it's our natural thing. You want progress, so you do all the stuff that you can get working quickly, and you get the 80 to 90% cases of your features working quickly, and then at the end you're left with all these 10 to 20% really hard chunks of your application. And the real danger is sometimes if you haven't addressed those up front, you push the 80% solutions for the different components in directions that make solving the remaining 10 to 20% incompatible. You have to backtrack to make things work. You've got to go and rip stuff out and say, yeah, we need a new approach here. Gutless estimating, this is upper management. Some of you already mentioned this. Upper management often doesn't want to hear a realistic estimate. And we'll talk later. One of your readings is going to be the thermocline of truth. When I'm a consultant, I'm called in on a troubled project. You know what I do for the first several days? Go around and talk to people. And the people I really want to talk to is not management. I want to talk to developers, people in the trenches. And usually within about 2 days of that, I can tell you exactly what's wrong, where the problems are. What you have is you have the situation is that truth typically does not flow accurately up the management chain. You have people who just pass along the good news and sort of, oh, well, you know, they think, well, we can cover this, so I'll just tell them, yeah, we're doing fine. And so upper management has a very unrealistic perspective on how the project's going. And we'll talk about this, but what it results is a pattern that I have seen literally dozens of times, which is you have this project, it's got a deadline, management thinks it's going well, it's going, and then about 3 weeks, it's almost always 3 weeks. In fact, Brooks mentioned this. I thought this was a novel, this is one of those things where I thought, hey, I discovered this, and I went back and read Mythical Man-Month. Brooks had it in there. 3 weeks before the deadline. Suddenly it's like, no, we're not going to be on time. And so they split the schedule for 6 months. And then it goes 3 weeks before the new deadline. No, it's not going to be on time. They split the schedule for another 6 months. I can't tell you how many cases I've dealt with as an expert witness where that literal pattern is followed. Completely different companies, completely different industries. Something built in there. I'm going to talk about cheap architect stuff later. So read it, but we'll hunt on that. Second system effect. How many of you have written a program and then have gone back to do your second version of the program and have thrown everything but the kitchen sink? That's the second system effect. In other words, trying to get the first version done, you build up this big list of all the features that you had to defer. And then you go to build the second one, and it's like, oh yeah, I'm going to do this, and it's going to do this, and it's going to do this. And usually what you do is you throw a bunch of stuff in, and then you start paring it down again. I will say, I've already said it, and I will say time and again, if you've got a project that's late, your only real solution is start pulling features out. And that's so hard to sell to management. But you defer features. Okay. Assignment for next week. I won't keep you here any longer. Watch one podcast. It says associated reading. I don't have any readings out there, so just watch a podcast. I've got links for some of them on the podcast page. I'll put the rest of the links in later today. Get your team's project wiki set up. Know the team members. You figure out how you're going to communicate as team members. Next week we will talk about roles in a team. That's why I'm constantly chief architect. Just let me finish talking. It makes it a lot easier. And now you're able to see that here in one class. Your first deliverable as a project is going to be an org chart. And so you need to start talking now among yourselves as far as who wants to do what role. Note that roles are not fixed. And I expect your org chart may well change. The one thing which I will emphasize next week is I want project manager and chief software architect as two separate roles. Whoever is managing a project and whoever is acting as the architect for the project needs to be two different people, and I'll talk next week about why that is. And read chapters 7, 11, 14 for next week. And that's it. I'll be for a few minutes if you have any questions.
Back floor is meeting in the Pinto Cafe.
Let's go over here. Jonah? Brittany? Jacob? Yeah. All right. You guys